This will be a generic description of how people see who have intermittent central suppression. Intermittent central suppression, as the name suggests, is an intermittent loss of sight in the central area of sight of either eye. What you have before you at the moment is the listing for a paper that uses the laboratory science to try to figure out how people see with intermittent central suppression, and that is available on the internet. What I'll do is start with a generic description of the eye aiming, and then move into my testing, and then into an animation of how people see with the intermittent central suppression. I think the underlying defect in intermittent central suppression is in the visual motion sensing apparatus. Motion is the on switch for everything visually. I use the analogy all the time of the mouse and the computer. And with the mouse and the computer, you have to keep the mouse moving in order to keep the screen awake. And when you're moving the mouse, what are you doing? Well, you're sending a message to the computer that the mouse is moving. And so it's that motion message that keeps the screen awake, keeps them from switching to screensaver. Well, eyes operate similarly. If there's not enough motion coming through, then the picture drops out, and you can show that experimentally, and I think that's what we see as intermittent central suppression. So let me first explain how eyes move. You can kind of see the eyes moving around there. And eyes are what are known in their aiming as an error detecting system. So what they do is get a little off target, figure out they're off target, and then switch back the other direction. So there's always some motion going on with eyes, both individually and together. Now, that means then that if one eye's picture drops out, the lock for that eye to stay with the other eye is gone, and all of the aiming mechanisms can get a lot more sloppy. And that, I think, is the root of the visual distortions that we run into with intermittent central suppression. So here are the slides I use to test for intermittent central suppression. Top left, you have the near target that is at 16 inches. Bottom right is a schematic, if you will, of the distance vectographic. Target vectographic just means polarized and allows us to separate out the two eyes pictures. And so if we go back to the near target, this portion of the target right here is covered up with the Polaroid overlays, so that the right side of it is seen by the right eye and the left side is seen by the left eye. When the suppression is significant, then one side will black out to the point that the underlying letters can't be seen. On the right, you see the distance target, and the panel on the right is seen by the right eye, the panel on the left is seen by the left eye, and then in the middle is a combination of the two. Obviously, those are not the normal acuity letters on the panels. That's just to show you how it combines. Down at the bottom, down here, is a distance depth perception test. We call that stereopsis. Stereopsis is the measurement we use for depth perception. And so let's see what happens in a test sequence where somebody runs into suppression. So this is the near target again, and this is the kind of thing that people will report. Half the target goes black, and then it comes back, and it goes black, and then it comes back. Keep switching back and forth. Sometimes it'll be more one side, sometimes it'll be more the other side. A lot of the time it will be both either side back and forth. About 80% of the folks with intermittent central suppression do alternate eyes. Now here's the distance target. I've put the actual acuity letters on there. Notice that the framework is seen by both eyes. but the acuity letters in this case are only seen by the right eye. So in a suppression, what we would see, looking at that target at distance, some of the letters go away. Then they come back. Maybe all of them go away. And then they come back. And so when they come back, then that eye has to realign its aim with the eye that stayed awake, if you will. And if we switch to the left eye, same kind of target. The framework is seen by both eyes, but the acuity letters are seen only by the left eye. So again, with a suppression, we might see this kind of thing. Letters drop out, then they come back, then they drop out, and then they come back. So now if we were to combine this into one single percept so that we could get an idea of what's happening between the two eyes. So what we'll do is we'll split the target down the middle, and that is not exactly how these acuity targets are built, but this will give you the idea of a suppression and how it flips back and forth. So left eye's picture might drop out, then it comes back. Then the right side, some of that might drop out. Then it comes back. This is very common. Left side might drop out. All the left side might. And then it switches to the right side dropping out. So what's happened there is one side is switched to the other side, and so there's been a direct flip from one eye's picture to the other. Now, an important point in all of this, what some of the laboratory science is showing us, is that when that eye's picture drops out, it's not a matter that the whole world goes black. Again, as the name implies, intermittent central suppression, it's the central area of sight. But what happens is the brain fills in that area with what's called surround in the vision science. And surround is just visual stuff that is the right color, right texture, so that it kind of fits in, but it doesn't have content to it, if you will. And so what happens then when this kind of thing is going on, and somebody's trying to, for example, reading is probably where we hear about most of the problems. And so one eye's picture drops out, that eye again can drift off target. And then it comes back, when the picture comes back, it has to realign with the other eye. And then the other eye's picture drops out. And so it can drift off target again, and then it comes back on. And so what happens then as far as looking at print, what would somebody see then? Well, again, think in terms of one eye's drifted off target, but we also have this fill-in that is just junk. And so that eye's picture has to, there's the junk, and that eye is off target, and now it interferes with the other eye. Now it's got to realign. And notice it's repetitive, intermittent. It's repetitive. It's an on and off phenomenon. So junk interferes, double vision realigns, and it just keeps happening. And there it goes again. And then that eye has to realign again. So these people who have this have a constantly changing visual world in their central, most precise area of sight. The hierarchy of problems that we hear about, reading is number one, spelling and handwriting is next. Math problems, usually that's when people hit story problems, or perhaps a column of numbers can be a problem. And then we run into sports problems, and these are as a group, these are the kids that are a little more likely to catch a fly ball with their face. Well, what's that about? You know, it's the same kind of thing. Let's talk about walking. And this probably means more when this is a trauma-based thing. Intermittent central suppression will happen with whiplash type trauma. So when the head gets bounced back and forth. So now you're talking about somebody who has seen well, but or seen with stable central sight, and then they have trauma, and intermittent central suppression is now how they see. And those people shift from a stable visual world to an unstable visual world. Now, one thing also that that I need to mention is that this is a separate thing from how you think of how people see. This is a separate thing from 2020. The vast majority of people that I see who have intermittent central suppression don't need glasses for distancing as you think of that. They see 2020. But the picture in their central vision is not stable. So let's go back to the person with trauma. And they so now they've always been able to see normally, stably, and now they've had trauma that creates intermittent central suppression, and this is how they see, with their eyes going on and off and the misalignment occurring. Now, obviously, this is something that can create dizziness, can make it difficult for people to navigate curbs, that kind of thing. Take that same person and stick them in a car, or maybe have them trying to cross the street. And so the car gets messed up, it's confused, and their eyes will correct for it and get it back together. But notice in the time that that's happened, that car is 50 feet closer to them. So these are the folks that when you're in traffic, you notice the people who can't figure out where to stop their car, and rather than getting at a stop sign, getting close to the person in front of them, they stop 10 feet back, and then maybe they'll creep up another 3 feet, and then creep up another 3 feet, that kind of thing. Again, depth perception and moving depth perception gets messed up because of the instability in the central area of sight. So that's what I think the vision science teaches us about how people with intermittent central suppression might see.